Welcome students, welcome to the non-ferrous metal session, unit number 6. Now in this session we'll start off discussing non-ferrous metal. Up till now we have discussed about ferrous and its alloys. So what content we'll be discussing? First important part of the non-ferrous and its application and composition, and very much important thing, that is classification of all the different types of alloys, that is non-ferrous alloys. So at the end of this lecture you will be able to classify the or name the non-ferrous metals and its alloys, and with that you will be able to answer the applications of those materials. So why to go for non-ferrous? Before starting with that, relatively high density is there for ferrous alloys. Again, comparatively low electrical conductivity of ferrous alloy is there. Again, one thing, it has a poor corrosion resistance, that is an inherent possibility of corrosion in some of the atmospheric conditions. But then also world uses 90 to 95% of ferrous and its alloys due to its important applications. So due to some of the drawbacks, we have to discuss the non-ferrous metals. So that's why there is need of studying the non-ferrous and its application. Now before moving further, everyone might have seen this type of can, that is Coca-Cola can, beverage can. So what type of material might be for Coca-Cola? It is nothing but aluminium. That is aluminium which contains some extra laying element such as 1% of magnesium, 1% of manganese, 0.4% iron, 0.2% silicon and 0.15% copper. So we can say that aluminium alloy of non-ferrous metal which contain iron as well. So if though it contains iron, it is not a solvent but it is a solute. So that's why it is an alloy of aluminium, we can say, which contain iron as an alloying element, not as a solvent. This thing you have to remember. So coming to the classification, metals are classified as first one ferrous metals which contains iron as a base metal, and non-ferrous metals which are or which doesn't contain iron as a base metal. In ferrous metal we have discussed steel, first classification, and second cast iron. Steel which contains less than 2% carbon, and cast iron which contains greater than 2% carbon. Whereas non-ferrous are further classified into two categories. First one is light alloys and second one is heavy alloys. So in light alloys it contains aluminium, titanium, zinc, whereas in heavy alloys, if non-ferrous, it contains copper, nickel, cobalt, bearing metals, etc. So coming to the first part we'll discuss in today's session is light non-ferrous alloys. So light non-ferrous first alloy is aluminium. So before going for alloys, we should understand what is aluminium. It is a FCC crystal structure element. Its melting point is 660 degrees Celsius. Next one, its density is 2700 kilogram per meter cube, which is too light, and elastic modulus of 70 GPa, and its appearance is silvery gray, and it has high thermal conductivity. Some of the important applications of aluminium is shown over here in the diagrams. So coming to the classification, first one, it is classified as casting alloys and wrought alloys. Two important things you should understand, it is casting alloys and wrought alloys. So in casting and wrought, first one we have is aluminium silicon or aluminium silicon copper alloy, and further are the names, that is LM2, LM4, LM6. We'll discuss the classification further. Next thing, we have aluminium and magnesium. So magnesium is added in an alloying element, so we have LM5 and LM10. Next one we have is aluminium and copper. So whenever copper is added as an alloying element, we have duralumin, that is LM11. And next one we have Y alloy. Y alloy is nothing but indicated as LM14. And last one is Hindulium, that is, it was the product of Hindustan Aluminium Corporation, that's why. So it contains magnesium and manganese and silicon as an alloying element. So coming to detailed classification, first one is Hindulium RR350, that is Hindulium Corporation product. It contains copper of 5% and nickel of 1.5%. So it produces high creep resistance. Specific application is aero engine. Y alloy LM14, as we discussed earlier, contains 4% copper, nickel and manganese of 1.5%. It retains high strength at high temperature and can be casted or rolled. What are the applications? Piston and heads of IC engines. Next one, LM11. As we discussed, LM11 is duralumin. So LM11 has a good strength and mechanical properties, which contains alloying element of only 4.5% copper and is used for aircraft castings. Next one, again duralumin type. Again it contains copper, manganese and magnesium. It is another type of duralumin, because one we discuss LM11 and one is duralumin specific. So it contains good strength, mechanical properties. Again application is aircraft industries. So it contains manganese and magnesium. In earlier it was only copper. Next one we have LM6, which contains silicon, pumps, water and cool jackets. Next LM13, we have silicon, nickel and copper. Again in that it is specifically used for forged pistons. Next one alloy is magnesium. So it contains magnesium, that's why the name magnesium, this thing you have to remember, and magnesium of 0.5%, specifically used for marine applications. L10 contains magnesium of 10%. So it is specifically used again for dairy equipments, good food product processing industries. One of the example of aluminium alloy is shown over here, that is, this is the wing of an aeroplane Airbus 340, which improved toughness, lower weight and increased resistance to fatigue and corrosion resistance is shown in the figure. Again another example, Jaguar XJ Saloon, which requires lower weight, so 300 to 400 kg load reduction of this vehicle was done, and which had saved 20%, or it has reduced 20% emission. Next one, aluminium classification percentage wise. That means first I told you wrought alloy type of aluminium alloy, and second is casted alloy type of aluminium alloy. So when you go for casted type, this is the nothing but series or designation of this type of alloys. So in this case, initially 2x indicates the minimum percentage of aluminum and last x indicates the type, that is 0 for casting and 1 for ingot. Next, titanium alloy. Again, before starting with titanium alloy, again it is a low non-ferrous alloy, lower density, high melting point of 1660, appearance again silvery gray. And what are the classification of this? That is alpha, near alpha, alpha, beta and beta. So these are the 4 types of titanium alloys which you have to remember. First one is alpha phase stabilizer and second one is beta phase stabilizer. So alpha phase, first one, what is the significance? It is alpha phase stabilizer, which contains ductility, maximum ductility with low to medium strength, good notch toughness, then good ductility I told. Specific example of this is used for jet engine components. Next one, near alpha titanium alloy. It contains alpha plus beta stabilizers, that means alpha stabilizers and near alpha stabilizers we can say, which are alloyed with 1 to 2% of beta stabilizers. One of the example is high performance ROW valves. Third one aluminum alloys, alpha beta titanium alloy. Its example is medical applications. Specific example you have to understand. Alpha beta titanium alloy used for medical application, that is bio implants and prosthesis applications. Next one, last one, beta titanium alloy, specifically used for critical aircraft structures or landing gears, since it possesses a very good grip resistance. That's why it is used for this type of applications. And next type we'll have is zinc and its alloys. Zinc is added in copper to form an alloys. So instead of going for its alloys, we'll discuss about the zinc. It contains, or it has 420 degrees Celsius melting point, hexagonal closed pack type of structure, good corrosion resistance, and specifically used for batteries. So this was about total low ferrous metals, low non-ferrous metals. We'll continue with heavy ferrous metals in next session. Thanks.